Welcome to Brain Vision.
In order to find our unknown compound, we're going to have to use a little bit of math to understand the relationship between our various elements, and we are going to be using a very simple systems of equation to understand how we would find the moles of our compound. So let's first note that our compound X is containing carbon, hydrogen, and oxygen. And we're told we have this reaction where we have X plus 3 diatomic oxygen that's going to be forming 2 moles of carbon dioxide plus 3 moles of water. Now, this is where it gets a little bit confusing mathematically. So we are going to have to find the number of atoms of each carbon, hydrogen, and oxygen. And this is the reaction we're going to use to do that. We know that C sub X, H sub Y, O sub Z, plus X plus Y over 4 minus Z over 2 forms X times carbon dioxide plus Y over 2 times water. This seems a little bit complicated, but all these variables are saying is that we have coefficients in front of our products and reactants, and we have a number that denotes the number of atoms in our compound. Now, from this equation, we can deduce that X equals 2 and Y equals 6. This was found by simply comparing this equation to the one above. And now we need to find Z. So we'll get X plus Y over 4 minus Z over 2 is equivalent to 3. And what this means is when we simplify it, Z is equivalent to 1. So that means our formula is C2H6O. Now, the way we know that this is a molecular formula, not an empirical formula, is because remember we're dealing with diatomic oxygen. And because oxygen is diatomic, we could have various empirical formulas. So this is how we found the number of atoms in our formula. Now our job is to draw our electron dot structures of how this compound can form. This first one will have a CH3 group that's bound to an oxygen that's bound to another CH3 group. And our second structure we can possibly have is a CH3 group bound to a CH2 group that then bound to a hydroxide group. These are the same formula, but we just rearrange them differently. Now the next step is we need to introduce ourselves to a concept called the enthalpy of formation. The enthalpy of formation is simply heat that we use or put into our reaction to form our products. And remember, this is our new reaction because we found our unknown compound. We have C2H6O plus 3 diatomic oxygen that's forming 2 moles of carbon dioxide and 3 moles of water. The way we would find our enthalpy of formation, which we denote with this symbol, delta H naught of F, we'll take our products minus the reactants. So we'll have 2 times the enthalpy of carbon dioxide plus 3 times the enthalpy of water minus the enthalpy of our compound C2H6O. Now, if you're confused as to why we don't have 3O2 in our formation, it's because it's in its elemental form, so we're not going to be including it. Now we just simply plug in the values of enthalpy of formation for each compound, and we'll have that the enthalpy of formation is equivalent to 2 times negative 393.5 plus 3 times negative 241.82 plus 1326.6. Now it's just a very simple calculation, and we'll find that the enthalpy of formation of our compound is negative 185.86 kilojoules per mole. So I hope that this problem helped you understand how we can find an unknown compound by simply knowing the atoms that make up that compound and the overall reaction. And I hope that this introduced you to how we can rearrange dot structures, and hopefully you now understand how we can find the enthalpy of formation, which is a very important concept.